Okay, let's get started. So, good morning, everybody.
Good morning.
Good morning.
Let's share my screen. Uh, Everybody, could you see my screen?
Yes.
Yes.
Okay, thanks. Uh, Today, we will start the new chapter. In terms of the book, it is chapter 10. And the chapter title goes Sinusoidal Steady State Analysis. This means today we will be starting the AC circuit, the actual one. Yeah. Like so far, we discussed that RLC transient, or even in the DC circuit course, you analyzed RL circuit, RLC circuit, transient circuit, all were based on the DC only. Never ever you applied any AC signal. But today we will be learning about the AC circuit, and we will be applying the AC to those components like RL and C. And as the title goes, steady state analysis, this means we will be applying the AC to the circuit, but we will not analyze the transient at this point. We will be only dealing with the steady state response. And this is actually the realistic system. At your home, at my home, everybody's home, you have actually the AC. It is not the DC. You have the AC system. So that's why we will be today extensively looking, and from now on it will be only the AC. So couple of things. First, we will be looking characteristics of sinusoids. Those AC signals look like sine wave or cosine wave. So that sine wave and cosine waves, those are called the sinusoid. So we will be looking what's their characteristics. And second bullet is forced response to sinusoidal functions. This means if we apply AC waveform or AC signal to the circuit, what is the forced response? Forced response means steady state response, not the transient. And then you see the third bullet phasor, or it is called the vector. We will be solving the AC circuit problem with the help of phasor. I mean, AC circuit is actually the time varying signal. It is time domain, but for simplicity, for ease of calculation, today we will be learning the new thing which is phasor. So therefore, I believe each of you need to have a calculator, scientific calculator with you. I mean, soon I am coming that point. And then from today, we will be learning the new term, new technical term, impedance and admittance. So far, we have learned resistance, capacitance, inductance. But today, when we will combine the effect of resistance, capacitance, inductance, that is called impedance. And this impedance for series circuit and admittance is for parallel circuit. And then also we will be doing some numerical problems. So soon I am coming those 2 points. So everybody please listen to carefully from now on. Uh, Everybody, okay, let me take to you the whiteboard first and then you will get fun. Uh, hold on. Okay, everybody say, in real practice, as I said you, at our home we have the AC. So what happens in real practice? For example, I have drawn on circular body and I am placing some coil in it. And this is on terminal, this is other terminal. Let's say this is plus minus. And this is another body. And on that body, I put a magnet, North Pole, and this is South Pole. And that magnet is attached to a shaft. This is the shaft. Okay. So everybody see, and that shaft is rotating. at a certain speed. For example, omega radian per second. So everybody see, in real practice, what happens? I'm talking about in real practice how the AC voltage is developed. So you need two things. This is on circular body. It is called stator. STATOR. This body is called the stator. So on the stator body, I have placed one set of coil, and there is another body. This circular body is called the rotor. This is in real practice. And on the rotor body, everybody see, I have placed a magnet. This is North Pole and this is South Pole. And that magnet is rotating. So therefore, in this portion, definitely there is some sort of turbine, or whatever it is, coal-based, oil-based, gas-based, steam turbine, nuclear turbine, wind turbine, whatever it is, with the help of the turbine, this shaft is rotating. Therefore, everybody see, this means this magnet is rotating, but this coil is fixed. Now, once you rotate the magnet, this coil is fixed. So here at the terminal, if you attach a voltmeter, you will get the AC voltage, and that voltage will look like this. Therefore, this is that sinusoidal voltage, and it is time varying. It is with respect to t. So we are measuring the voltage here. So this will be the voltage waveform. I mean, it will go in that way continuously. It is going high, low, again positive, negative. Continuously, it is going in that fashion. For indefinite period, it is going on. So therefore, this is the response of V. So now we can express this sinusoidal waveform in that way, like V equal to Vm cosine of omega t. That is the expression for this waveform. And then you all know, at least from the physics, because this is repetitive waveform, so it has a particular time period. So therefore you see, this is positive peak, this is negative peak. From this point, again, it is getting repeating. It is going upward and then coming downward, again going upward and then downward. So therefore, this is the zero position. From here to here, this distance is called the time period, capital T. And that time period, T equal to 1 over F, where F is the frequency. For example, for United States, the frequency is 60 hertz, that you all know. So therefore here we have frequency F is 60 hertz. So therefore you all know the definition of frequency, number of cycles per second. That is that number 60. So therefore this is on cycle, electrical cycle or waveform cycle, and this is the time period. Then again another time period. So therefore from here to here it is 90 degree. Then at this point it is 180 degree. Sorry. And then here it is 270 degree. At this point it is 360 degree. Then again it is repeating. So anyway, what I am telling you that AC system, this is the power generation mechanism or voltage development mechanism that is always in this format. It is called sinusoidal voltage, and it has a positive peak and it has a negative peak. Then again it will repeat. In that fashion it is going, and we have to express this on V equal to Vm cosine of omega t. Now here I am drawing one more thing. Once again. So just look this one cycle. So therefore, for example, this is the waveform of this signal, that V. So what is the Vm? Vm is this portion. From here to here, this amount is called the Vm. or from this point to this point, this is the negative side, this is minus Vm. So therefore, when I am writing the Vm, this is called the peak. This amount is called the peak or the amplitude of the waveform. So therefore, first of all, it is a time varying function. It is cosine of omega t or sine of omega t. That's why it is called sinusoidal waveform. Time varying. It has a magnitude. And it is going, you see, it is zero position. It is increasing, 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 going peak, coming down, down, down. And then again it is increasing negative side, again decreasing, again it is repeating, it is going in that way. The reason it is going high and low because of the magnetic effect. As I told you that with the help of the shaft, this magnet is rotating, but this coil is fixed. So therefore, when this north pole is coming very close to this coil, then it is getting peak. For example, currently voltage is increasing, increasing, increasing from zero position. When this north pole is properly aligned with the coil, then it is getting maximum. But then again, north pole is departing gradually, leaving this coil. So it is decreasing, decreasing. And then again, it is coming under the area of the south pole. You know the effect of south pole, north pole is opposite. That's why it is going negative side. In that way, it is varying. So anyway, everybody concentrate this equation. So this will be the representation of the voltage or same thing. Current also can be expressed the similar way. For example, I am cosine of omega t. For example, if that is the current waveform, this means this could be voltage or current wave for whatever. So same way you have to express. Again, this Im indicates that magnitude. This is Im. In case of voltage, it is Vm. So this is called peak or amplitude or magnitude. And then omega, you see, cosine of omega t, it is called angular velocity. You see, because this is moving and that omega radian per second, omega is 2 phi f, probably from the physics, you know. So therefore this omega is 2 phi f and f is the frequency. So therefore Vm is called peak or amplitude, but this V, this is called instantaneous. Let me write down it. This is called instantaneous. Yes. So therefore this small v, I mean small letter v, this is called instantaneous value of the waveform. This capital Vm, this is called peak or amplitude or magnitude. This means from here to here, this peak point or from here to here. And the entire thing, this is called the instantaneous value of the voltage. So instantaneous value of the voltage and peak value of the voltage. So everybody, could you follow me what I am saying?
Yes.
Yes, great. So therefore, I'm saving this one. Now go back to that slide. So now you will get fun. Yes, so look everybody, this slide. Actually, I am expressing this thing. This is the stator and rotor body, exactly same thing. So this means AC waveform can be expressed by this one, Vm cosine of omega t. And it is the waveform. This is on time period, capital T. This is 0. This is 90 degree or pi by 2. This is pi. You know pi means 180 degree. This is 3 pi by 2 and then this is 2 pi. So therefore, this is one cycle or one time period. And you see, just I explained those things. This amount is called peak or amplitude or magnitude. Now, when you will be solving the problem, in the problem statement, sometimes it will call amplitude, sometimes magnitude, sometimes peak. All these three terms are equally used. So therefore, you have to keep in mind, this means that this thing. And then, as I told you, it is called the instantaneous value. This is peak value, and then cosine wave form. Therefore, from today, as a electrical engineer, everybody, you will be remembering this term that AC waveform has to be expressed in this format, V Vm cosine of omega t. Now come back, moving forward. For example, everybody see, I have a series circuit here, RLC, and I am applying a AC source, AC voltage. See the symbol? Because it is alternating or time varying, accordingly this symbol goes. You remember, in case of DC, always you use like plus minus because that was the DC. But here, because it is AC, in most cases, this symbol is used. Now everybody say, for example, you have this series circuit, R, L, and C. So whatever the value is, those three components are there. And you are told, find out the current. So therefore, what will be the current? How you will calculate the current? When it was DC circuit, then always there are short circuit or open circuit, right? So for example, if it would be DC, then over a long time, inductor was short circuited and capacitor was open circuited. So in most cases, there was impact of resistance. Or in case a pure DC circuit, you always deal with only with R. You never ever deal with L and C. And you remember the DC circuit, you have learned many theorems like superposition theorem, Thevenin's theorem, Norton's theorem, delta Y conversion, whatever, Kirchhoff's current law, Kirchhoff's voltage law, current divider rule, voltage divider rule, whatever, always you deal with the resistance only. But in case of the AC circuit, it is not only the resistor, you have to deal with inductor and capacitor. And it is not the transient. It is not like, okay, transient happen or at steady state inductor becomes short circuited, capacitor open circuit. It will not happen in case of AC circuit. In case of AC circuit, always inductor and capacitor will be present as it is. It will not be shorted. It will not be open. So now the question is, what I am asking you, what should be the current expression for this circuit? So therefore, you see, I have written, will you add R plus L plus C in that way? And you will give a new name. For example, the combined impact is G. Will you do in that way? And then I equal to Vs over that number. Everybody, do you understand what I am asking? Yeah.
Yeah.
Yeah. So therefore, definitely answer is definitely no. That's why I have written here no. This means we cannot do this thing. Can you guess why? Because R is in ohm unit, L is in Henry, C is in Farad. Three different units. You cannot sum them up in that way. So as I told you, in case of DC, there is R1, R2, R3, you all them combined. But today, we are facing the problem. We have L and C and series, and all three have different unit. So you cannot just sum up in that way. So what I have done, now look right side, I have written the IT, current for this circuit. Now everybody see, in parentheses, I have used the symbol T to indicate it is the time varying signal. This means because the voltage source is time varying or sinusoidal signal, cosine waveform, accordingly, the current flowing in the circuit, it will also be time varying. Exactly the same thing. Now everybody see what I have written. IT is that Vs over capital G. I mean, I have used this symbol, that is fine, but G value is not this one. Now everybody see what I have written. I have written that,
Dr. Ali,
yes,
what is J in this case?
J is like complex operator. You remember the complex algebra or complex variable? For example, a number 3 plus j5. Oh, sorry, probably in math, you might have used the symbol I, like 3 plus I5.
Oh,
Complex number.
oh, a complex number. Oh, okay. All right. Thank you.
Yeah, so here in circuit case, mostly the symbol J is used, but in math, in most cases, symbol I is used, but it is the same. Everybody, could you follow me? I mean, the question she asked that
Yes.
if J,
Yes.
yes, this means this is a complex number. I mean, soon we will be solving problem and then you will get fun. I will show you how to do that. I mean, don't worry at this point. So everybody just look, for this circuit, the current is, I have written Vs over G. And what is that G? R. This R is this R as it is. But for this L and C, you see, I have written something new that so far you have never ever done before. So this means what I did plus J in parenthesis, I have written XL. I mean, XL is the impact of L and then minus X. Now the question is why I have put J and why I have put minus. I mean, later I am discussing. At this point, you just everybody, just you have a look at it ahead of time. And then now this combined effect, it is G, and you see, G is called impedance, and the unit is in ohm. Now R unit, you all know, that is resistance. That is fine. In the DC circuit also, it was the resistance. But everybody see XL, this term is called inductive reactance. Because it is the inductance, accordingly the name goes inductive reactance. The unit is in ohm. Xc, what is Xc? Capacitive reactance. Because it is called capacitor, accordingly the new term capacitive reactance and unit is ohm. Now you see, always unit is ohm, 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 ohm in each of these four quantity. That's why you can sum up this one. But here you see, again go back. I just wrote like G R plus A. You cannot do that because all three have different units. So this is not valid. Now see the definition. What is XL? What I have written, XL equal to omega L. And you know omega means 2 pi f L. Oh, sorry, I forgot to put the L. It will be 2 pi f L. And then what? This should be the XC. What is XC? 1 over omega C. This means 1 over 2 pi f C. I mean, I'll be changing this symbol. This will be XC, this one. And here I have to add the L. Somehow it got omitted. I'm sorry. So anyway, so I will be discussing you that how we got this thing. But at this point, from today, I mean, starting from today, from now on, as an electrical engineer, you must remember this format that for AC circuit, what is the equivalent impact of these three components? That is the impedance. So therefore, in case of the DC circuit, only you use the term resistance and you use the term conductance, G equal to 1 over R. In case of parallel circuit, parallel DC circuit, you use the symbol conductance, the unit was mho. But from today, in addition to resistance, we are looking two new terms that is coming from L and C, inductive reactance, capacitive reactance. Therefore, the whole, and it's a complex number. It is not just the real, it's a complex number. J means this part is imaginary. R is the real part, but this part is imaginary part. It is called. So the whole thing is the complex number. So now come back everybody that, okay, at this point, you hold on here. This is the expression. You understand that. Now I want to solve the current here. Everybody say, I want to solve current here. So this is my expression, Vs over G. So now whatever the value of G, I mean, how to calculate this thing, soon I am going to explain. Whatever the value is, let's say its value is 10, 10 ohm, for example. But you see in the numerator, there is Vs. And what is the expression of Vs? Vs is Vm cosine of omega t. You see, like it will be like that. Vm cosine of omega t. So therefore, if that is cosine of omega t, then again your it is in terms of omega t, cosine function. And then, for example, I told you, okay, find out the current across this component or this component, this component. So therefore, what will be the, sorry, I told you to calculate the power value through this or this or this. So what is the power through our I square R, right? I square R. But or what is the IT expression? It will be in terms of cosine of omega t, time function. Then if you make squared I square R, then that is going cosine square omega t. So therefore, just a moment. Let me go back. It will be much more clear to you. Just a moment. Okay, so everybody, what I am telling, for example, in a you have that series circuit. This was that voltage, that Vs. We are calculating the current I. That was my point. So, for example, after calculation, Vs over that G. For example, you got this format. Just an example. I am cosine of omega t. You got that is your current in time domain. Now, for example, this is R. I asked you, okay, find out what's the power value here, phi R. So this means you all know that phi R is that it will be I squared R, right? That you know. But then you see the I expression, I is Im cosine of omega t. This means it is getting then Im squared and then cosine square omega t and then R. So can you see then it became cosine square. And then this is simple RLC circuit, series circuit. But then for example, you have some parallel combination here. For example, this is your circuit. Again, I am making it complicated. For example, this is your circuit, or it could be much more complicated. And then I told you, okay, find out the power here. So therefore, you understand the complexity. So first you have to calculate the current, and then this current is going this way. Again, something is coming this way, something is going that way. So then can you understand how does the power expression may look like? Again, it can be cosine cube, cosine to the power 4, or multiplication of sine cosine. So gradually it will be complicated and complicated. I mean, it is not impossible to calculate. You would be able to solve, but it is very difficult to handle the cosine square or cosine cube or cosine to the power 4, those type of trigonometric function. And the problem is it is time varying function. So everybody, could you follow me what I am saying?
Yes.
Yes, I'm saying that it is AC. Okay, I showed you that how to calculate G. That is also fine. VS is that is fine. But once you calculate I, or for example, I said, okay, what is the initial power? What was the input power? So therefore, for input power, what you will be doing? Again, you will be multiplying, like Vm cosine of omega t, that is the V value, then multiplied by that Im cosine of omega t. Therefore, see the complexity. complexity is here, again it is getting cosine square omega t. So this is just the input part. Once you are asked in a complicated circuit, series parallel circuit, there will be delta Y combination and much more complicated circuit, you will fully end up to calculate and manipulate. As I said, it is not impossible, it is possible, but very, very difficult, time consuming. That's why, in order to simplify the situation, to make easy the calculation, there is a method. That method is called the phasor. That we will be looking from now on. Sorry. This one. So therefore, for example, we are discussing this one. Now come back. This will be the technique. So what is the phasor technique? A phasor is a complex number that represents the amplitude and phase of a sinusoid. So, and then for example, look the voltage expression Vt Vm cosine of omega t plus theta. I have added one thing. So far I only told you Vm cosine of omega t, but I am adding another angle. This is called the phase angle. This is called the phase or phase angle. I mean, always it is not like that it will be only Vm cosine of omega t. Always there can be some angle. I mean, theta can be 0 or theta can be 5 degree, 10 degree or some angle. It is called the phase. It is called the phase because it might not start from that 0 position. So once again, for example, it might be the situation that instead of starting from here, the voltage might start from here. You see, instead of starting from 0, it might start from here. And from here to here, this distance can be, for example, just an example, 10 degree. Or the voltage might start from before. It might happen in that way. So in that case, again, this distance could be 10 degree. So accordingly, if that is the case, you have to add cosine of omega t plus or minus. It could be plus minus that theta. I mean, it could be after 0 or it could start before 0. Accordingly, you have to put plus or minus theta. This theta is called that phase angle. Phase angle, or simply it is called the phase. So you remember that thing. Okay, so now let me go back there. Okay, that's why in the expression you are looking Vm cosine of omega t plus theta. Now what I am doing with this one, I want to apply the phasor. And what is my definition? Phasor is a complex number that represents the amplitude and phase of a sinusoid. Therefore, you see, if this is my expression in time domain, including that phase, I can write in phasor form capital V. See the symbol? Here it is a small v in parenthesis t to indicate time domain function. What I am doing here? Capital V, Vm, this Vm is this Vm, and what I have written? E to the power j theta. This theta is this theta, and which is equals to this Vm, simply angle theta. This means that you can express a time domain function into this format. How to do that? Simply that peak or amplitude, whatever it is, and see if there is any phase angle or not. Now, if this is 0, for example, there is nothing, just cosine of omega t, this value will be 0. If it is 5 degree, then 5 degree. If it is minus 10 degree, then it is minus 10 degree. So therefore, and then how I get this one? Now see everybody, this one. First line was this one, but second line what I did, RE means real. You see, this is cosine function. So look in bracket, Vm e to the power j omega t plus theta. So therefore this one is the real of this one. So can you guess what is this one? E to the power j omega t plus theta. This is the Euler's function, Euler's theorem. E to the power j theta is cos theta plus j sine theta. Then once again, I think I need to take you there. Everybody hold on. Okay, so what I was telling, everybody, can you remember this one? E to the power j theta or I theta. What is this one? Cosine of theta plus
Omega theta.
no, plus j or I, whatever, j sine theta. Everybody, can you remember this one? This one is called, sorry, this one is called Euler's theorem. Sorry. Euler's theorem, this one is called. Can you remember from the math, everybody? E to the power j or e to the power I theta cosine theta plus j or I sine theta, this thing?
Yeah.
Yes, I believe everybody have studied in math. It is called Euler's theorem or Euler's identity. So this means that this is a complex number. Cosine theta is called the real part. The sine theta is called the imaginary part. And then the whole thing is the complex. So that thing I was showing you here. Look this one. So because at the beginning, I have written Vm cosine of omega t plus theta. That's why in second line, I have written Vt. This one is the real part of this one. Because I can write this on cosine of omega t plus theta plus j sine of omega t plus theta. So that's why this is the real part. And then after that, you see, I just decompose into two components. This Vm is Vm. You see, because this is plus, plus means this is multiplication. E to the power j theta one term and e to the power j omega t another term. Everybody, could you follow me? Is this correct?
Yes.
Yeah, so yeah, you just remember your past knowledge or math knowledge. These are not the new thing. Everybody, you know. Now my goal in the phasor, I want to express, phasor is a complex number that represents the amplitude and phase. I don't want to use any t function. I want to eliminate the t for the sake of simplicity. So that's why, because e to the power j omega t, I am avoiding this part at this point. Simply, I am considering this part. This is the phasor. That is the definition of phasor. Therefore, instead of doing in that way, what you will be doing when solving problem, whatever the voltage or current expression is, you will be looking this one and you will be taking that peak Vm and e to the power j theta, whatever theta. Or simply you will be writing Vm that angle. Similarly, in case of current, that phase angle could be different. Just an example, I am e to the power j phi, I am angle phi. For example, this angle could be 10 degree, this angle could be 5 degree or other value. That is the meaning. So this means that from now on, instead of using the time function, always and in your real life, you will be using this type of expression to indicate the AC waveform. So in other words, when I will be solving this problem, I want to solve current. Vs will have an expression like 100 cosine of omega t plus 10. Then I will convert that expression into phasor form. Similarly, you see in the denominator, as I said, this will be the G, combined impact of this one, which I am calling impedance. Again, because there is J, you can express this on in phasor form. Therefore, both your numerator will be in phasor form, denominator will be in phasor form. And then you can solve any problem because it is independent of time. Then you got the result in phasor form. Finally, because your problem was actually in time domain, V is actually time domain, you have to convert back into time domain. So this means what I am telling, for example, you got current in this format or voltage in this format. So how to go back there? Therefore, see, for example, you have a current expression this. So how you will go back in the current format? I am cosine of omega t plus phi. Look this one. For example, you got a result like that. How to go back there? Simply write Vm cosine in parenthesis omega t and add that angle. Do you understand what I am telling? When you will be solving the problem, at first, very first task, you have to convert every time domain function into phasor form in this format, magnitude and angle, and then you solve whatever series parallel, whatever the big network is, you are able to solve. Then finally, once you get the result, then again convert back into time domain. Just one line. Now the question is, now what is the problem? I believe you are facing on problem. The problem is that, for example, for this type of network, for example, you solve the power here, for example, and you got this type of result. Just an example, 100, and it has 10 degree, just an example. And then at some point, for example, here the current value, for example, you got, just I am giving random example, 5 degree. And then, for example, your V value was just another number, 15 at an angle of 10 degree, just an example. Now, for example, somewhere you need to multiply these two, or you need to divide these two. So the question is, if you want to divide voltage over current, you need to do that. Then in your numerator, it is 15, and then your angle is 10 degree. But in the denominator, it is this one. I mean, the thing is that there is no time function here. We eliminated. I am using the phasor format, but the question is how to operate this one, because there is angle. So therefore, how you will manipulate, or what will be the result, how you will do that. That is the thing today in class. With the help of calculator, we will be learning, which is called phasor calculation. So how to manipulate, do that. Or for example, you want to subtract. For example, you have, for example, you have a number, just 5 at an angle of 3 degree. You want to subtract, for example, 2 at an angle of 1 degree. So how to solve that one? Because I understand that I will be avoiding time domain, I will be expressing everything, every component in this format. But then because this is series parallel, I have to make parallel, I have to add, I mean the series combination, I have to find out voltage, current in any branch, whatever. And many times I will be facing this type of problem. Or for example, I need to sum up these two, or I need to multiply these two. The question is how to do that, because there is angle. You cannot say that, okay, this is 10 and this is 3 degree. You cannot say that. The answer is different. How to divide it here? Everybody, could you follow me what I am telling?
Yeah.
Yes. So therefore, at least everybody understand that these formats are easier because there is no time function. But the problem is that how to solve that. That thing I am telling, because there is angle. That thing today we will be learning, which is called the phasor system. That thing. So therefore we understand that, and now we are going. Everybody say, I am going to phasor algebra. Now we have to learn something new before solving any problem. Therefore, everybody see, I mean, what is the context of the thing? Just look, just at a look. I mean, don't worry, everybody just look the problem. For the circuit in figures 1 and 2, determine current IT. Look, this one very simple circuit, there is only R, even there is no LC. Look this circuit, there is a voltage source, 1.5 kilo ohm resistance, but then 1/3 Henry capacitor. And then I am asking find out IT. And then this is another circuit. And again, I am asking, okay, find out the equivalent impedance. So you can guess that, okay, these two are in parallel, series, and again parallel. In this case, these two is in series and then parallel with this one and then series with this one, right? But you see how to do that. So this means that you have to convert the first attempt will be you have to convert including the voltage source or current source into phasor domain. Every component first you have to convert into phasor domain, any problem, and then we will be applying the phasor algebra. So that's why today we will be learning that phasor algebra. And then for example, again I am going just an example. Everybody look at the bottom what I have written. 3 plus J4 equal to 5 at an angle of this. So that is the thing. With the help of calculator, today everybody, you will be practicing with me. For example, this example first. 3 plus J4 is this. Or you have given right side, can you go back this format? We will be learning those things. Then we can solve any circuit problems. I think everybody is understanding what I am telling. So has anybody ever used in math this type of format for any calculation? Have you
Yes.
used? Okay. So you know, and then if you have a scientific calculator, then easily you can do that. Yeah. So that is the thing we will be learning. So therefore, first of all, everybody see, here are some rules. So therefore, I mean, after one more class, after Monday's class, I will be assigning the second set of homework. That time you will be opening these phasor algebra rules, you will be looking example, I mean, this class lecture, Mondays, then you will be able to solve. But at this point, everybody look carefully. So because we are dealing with the complex number, I think you all are familiar with this. And you see, this is x, this x is y, here it is my g vector. The magnitude of this one is r, and then the angle here is theta. So how you can express this one? I have written, it is called rectangular form. Z, this one, x plus jy. This is a complex number. So this format is called rectangular format. Then see next, you can express this one in polar format. Can you everybody see? Well, yeah. So r, g is r, angle theta, because this angle is theta, and this magnitude is r. Or in exponential form, you can express g r e to the power j theta. This means you can express this one, I mean this representation in any of the form. All are the same thing, either rectangular form or polar form or exponential form. So when we will be solving the numerical problem, we will be solving the circuit. Mostly we will be dealing with this two, polar form, because you know this is the form that we learned just now, phasor form r theta. Sometimes you might need to use this one, because when you will be adding two numbers, for example r theta plus another number p theta, you cannot add in that way easily. So you have to take the help of rectangular form. So therefore, frequently you have to go from here to here or here to here. Those things we will be looking. Therefore, everybody say, for you I have written, for example, everybody look, you have a complex number g on x1 plus jy1, which is r on theta 1. You have another number g2, this one. And then I am doing addition, subtraction, multiplication, division. So what I am doing, if you have two complex number, how to add that? G1 plus G2. Look this one. You add the real part, x1, x2, plus imaginary sign y1 plus y2. I think everybody understand this one. Then for subtraction, z1 minus z2, see x1 minus x2 plus j y1 minus y2. This is fine. During multiplication, I am using this polar format around theta 1. So what I am doing, everybody look, during multiplication, r1 multiplied by r2, and what is the angle? Theta 1 plus theta 2. This means that when you will have two phasors in this format, if you want to multiply, just multiply their magnitude and angle, you just add, you just sum up that one. How to divide that one? r1 over r2, and then angle is minus theta 1 minus theta 2. Therefore, because we will be solving current, voltage, impedance, that time this type of operation will come. Accordingly, we have to use these things. And then other thing is called complex conjugate. Everybody know, for example, gx plus gy are at an angle of theta. G star, I mean, this is called complex conjugate. Just you have to change the sign. It was x plus j here, it is x minus j, or it was r theta here, r minus theta, or e to the power minus j theta. I think everybody know what is complex conjugate. If you have a complex number, what is its conjugate? That's why here symbol G, here symbol J star. Just use the minus sign. If you have a minus sign here, put the plus sign here. That is the meaning. Now, what is this value? Root over G. So what was my G? So this one, look this one. What was my G? G is R at an angle of theta, polar form. So if I make root G, what will happen? Root over R for the magnitude, but make root square, angle will be divided. Because you know root G mean J to the power half. That's why angle will be half. J to the power n. You want to make square or third power or fourth power. How to do that? That r to the power n, whatever is, an angle will be multiplied. And you see, you all know this thing. What is 1 over j? Minus j. Or 1 over I minus I. So these things, this is the thing. So this slide is very important. Always keep you in handy. You will be looking, then over the time, everything you can memorize. But at the beginning, couple of days, everybody, you will be keep this thing handy to solve the phasor problem or the circuit problem. Then you will be fine. Everybody, could you follow me what I am telling?
Yes.
This is just the phasor algebra rule, how to solve that voltage, current, impedance, reactance, XL, XC values. We need these rules. Now everybody come back. So therefore, those you already know these things do, or otherwise, everybody right now, if you have calculator, please everybody, you tell me that you are able to do that in your calculator. For example, you write 3 plus j4 and tell me that you are getting this number. So you see, left side is called rectangular form, right side is called polar form. So you do two things. First, you look your calculator, you use left side and tell me that you are getting right side. Next time, you convert from right side and then you tell me that you are getting this one. It is called polar to rectangular. Rectangular to polar, polar to rectangular. So therefore, you see, I have a, can you see, like I have a, you know, that somewhat old computer, I mean, 20 years back calculator. It is like Casio FX 350 ms. So I have written for you how to do that. When converting from rectangular to polar, this means right now this example, 3 plus j4, and then you do this thing. In your calculator, first press polar sign, that button, then write the real number. Real number means 3, put a comma, write the imaginary number. Imaginary number means 4. You don't need to write j. And close the parenthesis, then press the equal sign. It will give you the magnitude of the polar format. This means you will be getting 5. How to get angle? Then press the alpha button and tangent button. it will give you the angle for the polar format. So this is the rule for my calculator, Casio FX100C. Let me show you just a moment. Everybody, can you see my calculator?
Yes.
Yeah. So don't laugh at, this is my old calculator. I mean, I purchased in Japan in 1998, 22 years back, and still it is working. So still I am using. I believe you all have very good and latest calculator. So I wrote those rules based on this calculator. So therefore, see my calculator, everybody. Let me turn on. I turned on, and then it was 3 plus J4. I want to convert from 3 plus J4. So how to do that? So first you see, can you see here that polar button and rectangular button here? It is written, see your calculator. So first I want to convert, I want to go into polar form. So I pressed polar, that button. See the screen. Then I put number 3. First I put number 3. Then give the comma. I give the comma. Then it was 3 plus J4. I put that 4. I close the parenthesis and I use the equal sign. You see that it came 5. And once you get 5, how to get the angle? Press the alpha button. This is my alpha button. And then use the tan button. So this is the tan button. And then put equal sign. You see angle 53.13. Everybody, could you follow me?
Yes.
Yes. So please, in your calculator, as I told you that this one is, kind of 20 years old calculator. Of course, scientific, still it is working. You see your calculator, you look the various function, or you see the instruction in your calculator, how to convert rectangular to polar and polar to rectangular. That's the thing. So, because this is my result, so next time I am showing you how to go back. For example, 5 at an angle of 53.13 is available. Now I want to go back to rectangular. Now everybody see, this is my rectangular button. So I have to press shift, this button. First I will write first number 5. Then I will put comma, and then I will put angle, just 53.13. Just you write the number and then close the parenthesis, put the equal sign. You see, you got 3.000. This means first you got the real part of the rectangular. Then again press the alpha button, press the tan button, press equal sign. You see 3.9999. This is mean this is 4. So I got 3 plus J4. You don't need to write J. I mean, the second part is the J part. So I think everybody understands. So now let me go back there. So everybody, so are you getting this thing? Are you, everybody, are you able to get from left side to right side and right side to left side? So therefore, everybody, you must be able, you should be able to do that. Otherwise, you cannot go ahead. You cannot solve any problem of the AC circuit. This is mandatory part, everybody can. So therefore, please confirm me that you are able to get this on in your calculator.
Yes, I can.
Yes,
I
great.
can as well.
Yes, I can.
Yes, yes, great. Yeah, I mean to test both ways. From right side, you can go left side or not. Yeah, both way you try. So based on my calculator, you see my calculator is Casio FX350 MS. Based on that, I have written down how to do that. Yeah, you see your calculator and please you make sure. Okay, assuming that everybody you learned, and then please go to the next slide. Everybody please try these two. I have done some calculation. Everybody see. Just two example. You practice. Everybody practice. Evaluate the following complex number. You see, everybody look number on 40 at an angle of 50 degree plus 20 at an angle of minus 30 degree, then whole thing is basically root over. So that's how I have given the power half. That half power is to the whole part. You see 40 at an angle of 50 plus 20 angle minus 30, then whole thing to the power half. So I got this result. You see my result, 6.9 on angle 12.81 degree. You tell me that you are getting this result. And then the second problem is there is numerator and denominator. In the numerator, I have 10 at an angle of minus 30 degree plus in parenthesis 3 minus j4. In the denominator, 2 plus j4 multiplied by 3 minus j5 complex conjugate. This means in the denominator, only for this part, you have to make complex conjugate, not this one, only this one. Therefore, see in the next line, I have changed this on 3 plus j5. And then finally, I got this result. You please tell me that from this operation, you are getting this result, 0.565 angle minus 160.13. This is just practice. Everybody please make practice in your calculator that you are able to get this one. And from this one, you see my calculation I did for you. Look the sign and everything, and I got this result. This means that you will be facing this type of calculation in the AC circuit to calculate voltage, current, impedance. If you cannot do that, this means you cannot do any calculation. That's why this is mandatory. Everybody, you must learn this thing, how to do that. So has anybody so far got, for example, number on this result? So therefore, I think you may have another class. So everybody, what you can do, you can try at home, because I already uploaded these slides, class lecture 6. You see that class lecture 6 already I uploaded, or later you can see the video I will be uploading. And then everybody, please practice at your home. And next class, you confirm me that everybody are able to get that on. Yeah. I mean, you see my calculation, already I did, but you practice in your calculator that you are getting the same result. That is the thing you have to do. So is everybody fine? So I think I suggest you to do at home these things. You practice this slide. Is this okay?
That sounds good.
Yeah. So because like it has been 10:14, some of you might have other class. So I am stop sharing. So I think everybody understood what I am telling you to do. Everybody, please, you make practice. And then once everybody is fine, you have to confirm that 100% you are able to do these operation. Only then I will jump to the circuit solution problem. If you have any issue, then you can't solve any problem from now on. Therefore, from now on, always, I mean, everything is the same, Norton theorem, superposition, Thevenin, Kirchhoff's current law, voltage law, everything is the same process that you have learned in DC. Only difference it is in AC, and it will be in that format. That is the difference. Okay, so at this point, I am stop sharing. You all do. So